Hari Om children. Previous session we have learnt about multiples, factors and common multiples. Now in this session we are going to learn what are prime numbers, what are composite numbers, co-prime numbers, twin numbers and how to divisible the number. Now first we are going to see what are prime numbers. What are prime numbers? The numbers more than 1 whose only factors are 1 and the number itself are called prime numbers. Here what is the statement given? The number which is having only 2 factors, that is more than 1, means suppose I have taken the number 5 and 5 is divisible only in 2 numbers. What are those numbers? 1 and the number itself. Such type of numbers are known as prime numbers. Which number can't be divisible other than one table and the number itself? Those type of numbers are known as prime numbers. One more example I am taking here, that is 23. 23 is also divisible in only 2 numbers, that is 1 and 23. These 2 numbers only we can see that can divide 23 exactly, and other than these 2 tables we will not find any factors dividing the number 23. Such type of numbers are known as prime numbers. Now next one is our composite number. What is meant by composite number? A composite number is defined as a number having more than 2 factors. I told you about factors in the previous class. Factors means the number which we are taking can be divisible in many tables. That type of numbers are known as factors. Now what is meant by composite factor here? For suppose I have taken the number 9. 9 can be divided in 3 different tables, that is 1, 3 and 9. 1 9s are 9, 3 3s are 9, 9 1s are 9. These are the 3 numbers. Therefore it is a composite number because it is having more than 2 numbers, 2 factors, which is having more than 2 factors. Such type of numbers are known as composite numbers. So 9 is a composite number. In the same way, I have taken one more example, that is 14. 14 is also having 4 different types of tables. 1 table, 2 table, 7 table, 14 table. 1 and 14 are common. If 1 and 14 are common, no tables are found. That is known as prime number. But here I am having more than 2 factors. 2 and 7 is also included for 14. That's why 14 is known as composite number. Prime number means the number will be divisible only by 1 and the number itself. What is meant by composite number? It is having more than 2 factors. That is known as composite number. Now we will identify what are prime numbers from 1 to 20. Prime numbers from 1 to 20. Here I have taken some numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Till 11 I have taken. We will see whether these numbers are prime numbers or composite numbers. 2 table will be dividing in only 1 and 2 tables. So only 2 factors, that is known as prime factor. Next 3, 1 and 3, this is also prime factor. But 4, here we are having 3 different tables, that is 1, 2 and 4. It is having more than 2 factors. That's why what is this number called? It is called composite number. 5 is having only 2 factors. So if it is having only 2 factors, number and the one number itself and 1, then that number is known as prime number. What about 6? 6 is having 4 different tables. So it is having more than 2 factors. That's why it is known as composite number. 7 is divisible only by 1 and itself. That's why it is known as prime number. 8, it is having more than 2 factors, so it is a composite number. 9, more than 2 factors, composite number. 10, more than 2 factors, composite number. 11 will be divided only by 1 and 11 itself. That's why it is known as prime number. Coming to the next column, I have taken from 12 to 20. So 12, if you observe here, you can see number 6 numbers for having for 12. 6 numbers are there for 12. So 12 is a Yes, it is a composite number because it is having more than two factors. What about 13, ma? 13. It is having only two factors, 1 and the number itself, that is 13. So it is known as prime factor. 14, if you observe 14, you are having more than two factors. That's why it is known as composite factor or composite number. 15, it is having more than 2, so it is also composite number. 16, more than 2 factors, composite number. Coming to 17, it is having number itself and the number 1. So this type of numbers are known as prime numbers. 18, more than 2 factors, composite number. Coming to 19, it is having only 1 and number itself. That's why it is known as prime number. Coming to 20, it is having more than two factors. That's why it is known as composite number. Numbers having only two factors are known as prime numbers. Numbers having more than two factors, it is known as composite number. Note, 1 is neither prime nor composite number. We will not consider 1 as a prime number or composite number because any whole number we consider, all the whole numbers are greater than 1. It is greater than 1. That's why we will not compare 1 as prime number or composite number. We are having one more identification of prime numbers. What is that identification of prime numbers? Eratosthenes C. He is a famous Greek mathematician. He is also an astronomer and he is a geographer in Egypt in 200 BC. In 200 BC. Eratosthenes was a Greek mathematician, astronomer and geographer in Egypt in 200 BC. He invented a method for finding prime numbers that is still used today. Eratosthenes was a Greek mathematician. He identified how to find out and how to remember prime numbers. We will see the table how he identified the prime numbers till 100. If you observe the table here, in that table you can identify the numbers striked out and some numbers are not striked out. If you observe this, the numbers which are striked out, that numbers are available in other table also, but the number which is like 2, 3, 5, 7, those are having only two numbers, that is number and 1. So such type of numbers are known as prime numbers and the crossed out numbers are known as composite numbers. How we have identified this and how we have cutted the numbers, we will see now further. So, it filters out numbers to find the numbers. Step 1. Cross out 1 since it is neither prime nor a composite number. We will strike off 1 because we will not consider it as a prime number nor a composite number. Now, what is the second one? Encircle 2. All the numbers divisible by 2 or even numbers. So, cross out all the multiples of 2. Don't strike off 2 because 2 is a even number and we have to strike the numbers which are coming in 2 table because 2 is having only two factors, that is 1 and the number itself. That's why we will not strike off 2 but we will strike out the multiples of 2. What are multiples of 2? 4, 6, 8, 10, 12, 24, 26, 28, 30, 32, 34. All the even numbers which are divisible by 2. Such type of numbers are struck in the table. Now, encircle 3. Don't strike out 3, leave it like that only because 3 is also having only two factors, 1 and number itself. Cross out all multiples of 3. In the same way, 5 table, don't strike 5, cross out all 5 tables, multiples. Circle 7, don't circle 7, leave like that only, cross out all multiples of 7. In the same way, don't strike 11, remaining multiples of 11, you strike it off. All the encircled numbers are prime numbers. Rest all the crossed out numbers except one are composite numbers. We are not going to tell one as a prime number or composite numbers. So leave one. And remaining numbers, when you are not going to strike out, when you are striking out multiples of 2, multiples of 3, multiples of 5, multiples of 7 and multiples of 11, the remaining numbers we are leaving out. Which are the numbers we left? It 2, 3, 5, 7, 11. So we are leaving them and remaining all the numbers we are striking. And the numbers which are we are striking, in that also we are having some numbers which are not striked. If you want to observe here, observe 13, 17, 19, 23, 39, 31, 30, so on till 100, till 97. These are the numbers which we have not striked in the table. This type of numbers are known as composite numbers. When you are striking the multiples of the table 2, 3, 5, 7, 11, the numbers are totally striked. The multiples are striked out and remaining numbers are left like that only. Lefted numbers are known as prime numbers and strikeout numbers are known as composite number. This is how Eratosthenes has proved that prime number identification. Now we will see what is coprime numbers. What are coprime numbers? Any set of numbers which do not have any other common factor other than 1 are called coprime or relative prime numbers. For suppose if you are taking two numbers, in the two numbers if you find only one as the common number, digit 1, if you find only digit 1 as a common number, that type of numbers are known as coprime numbers. Factors where you find only digit 1 as a common number, that type of number is known as coprime number. Here I have taken the factors of 5 and factors of 6. If I am taking like that, factors of 5 are 1 and 5. Factors of 6 are 1, 2, 3 and 6. If you compare these two factors, what you will identify? You will identify the common factor is only 1. Therefore, these two numbers are known as coprime numbers. Coprime numbers means what, na? The factors in two numbers have a common factor of digit 1. Those type of numbers are known as coprime numbers. Now we will see properties of coprime numbers. What are the properties of coprime numbers? All prime numbers are coprime to each other. All prime numbers are coprime to each other. Any consecutive whole numbers are always coprimed. Consecutive whole numbers are coprimed. Sum of any two coprime numbers is always coprimed. Coprime numbers need not to be prime numbers. Coprime numbers will not be prime numbers always. It may be any number, but there should be only a common factor of 1. Sum of any two coprime numbers is always coprimed. When you are adding the coprime numbers, it is always forming a coprime number only. Any consecutive means alternative numbers always finds a coprime numbers. All prime numbers are coprime to each other. Even if you take prime numbers, those numbers also comes as a result of coprime numbers to each other. We will say about twin numbers. What are twin numbers? Twin numbers are a pair of primes which differ by 2. First few twin primes are here. Now, twin prime numbers means what, ma? When we are taking two prime numbers, the difference between two prime numbers should be 2. What are prime numbers? Prime numbers are the numbers which are only having two factors, that is 1 and the number itself. So, if I am taking such two prime numbers and the difference between those two prime numbers is 2, then those two prime numbers are known as twin prime numbers. Here you can see some examples I have taken. I have taken 3 and 5. Now, when I am subtracting these twin prime numbers, I should get the difference of 2. So, what is the difference of 5 minus 3? It is nothing but the difference is equal to 2. Right or wrong? Yes, it is 2. In the same way, wherever you take two prime numbers which are having the factors of 1 and the number itself, And when you are taking the difference of both the prime numbers, you must get the difference of 2. When you are getting the difference 2, those prime numbers are known as twin prime numbers. And 3 and 7 also prime numbers only. But the difference when you are checking in a 3 and 5, 3 and 7, how you will get a 7 minus 3? What is the difference between 7 minus 3? It is equal to 4. 4. The difference is 4. It's not 2. But when you are taking the difference between two prime numbers, the difference should be 2. Here I got 4. So these two prime numbers are not twin primes. Twin primes are the numbers where two prime numbers will give the difference of 2. Now here we will see the divisibility rules. Tests of divisibility of numbers. How we are going to divide a number. So here my first number is divisibility by 2. How I am going to divide a number by 2? If the number ends with 2, 4, 6, 8 or 0, it is divisible by 2. Means what, Nana? The ending digits of any double numbers or triple numbers should be the multiples of 2. If you are going to check your 2 table, what you will get? 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, 2 fives are 10. In double digits, the tens place value is 1 and ones place value is 0. So, we have to calculate ones place value digit. When you are considering like that, 0 will follow on the 2 table. So, now 2, 4, 6, 8 and 0 are divisible by 2. And here I have taken 3 numbers, that is 28, 54 and 96. If you observe here, what is my ones place value here? 6, 4 and 8. Now, if you compare these numbers in 2 table, 8 is in 2 table? Yes, 8 is in 2 table. 4 is in 2 table. 6 is in 2 table. So, all these 3 numbers are divisible by 2. Here, 28, 54 and 96 ends with the 8, 4, 6 respectively. Therefore, these 3 numbers are divisible by 2. So, all the ending digits in the ones place should follow the multiples of 2. Then only it is divisible by 2. Now, we will see the divisibility rule for 3. What is the divisibility rule for 3? We will see now. What is the divisibility rule for 3, Nana? If the sum of the digits of any number is divisible by 3. What is meant by sum? Sum means you have to add all the digits what you are taken in the number. Then only it is divisible by the number 3. For example, I have taken a number 429. 429. Now I am adding all the 3 digits. 4 to 9 I am adding. How I am going to add? 4 plus 2 plus 9. When I am adding all together these digits, what is the product I am getting here? Sum I am getting? I am getting 15. Is 15 divided in 3 table? In 3 table you can find 15? Yes. How? Read 3 table ones. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12, 3 fives are 15. So, 15 can be divided in 3 table for how many times? By how many times? It is 5 times. So, the number 429 is divisible by 3. Only simple indication. Add all the numbers what you have taken in the number, see the answer what you have got and check whether the answer you got is divisible in 3 table or not. If it is divisible by 3 table, then the given number is divisible by 3. Now we will follow the next rule, that is divisibility rule by 4. Divisibility rule by 4. If the last 2 digits of any number are divisible by 4, then that number is divisible by 4. What is the condition here? If you have taken any larger number, the last 2 digits means which is under ones place value and tens place value. You have to consider ones place value and tens place value and you have to see whether that last two digits are divisible by 4 or not. For example, I have taken a number 628. My total number is 628. Now, What is my last two digits? My last two digits are 28. Now I have to check whether this 28 is divisible in 4 table or not. So read your 4 table. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 sixes are 24, 4 sevens are 28. So 28 is divisible in 4 table. How many times it is divisible? It is divisible by 7 times. 28 divided by 4 will be giving the answer 7. It is exactly dividing by 7. So the number 628 is divisible by 4. Now we will see divisibility rule for 5. What is the divisibility rule for 5? If the digit in the ones place of a number is 5 or 0, then it is divisible by 5. If you compare your 5 table, what you will be getting your place values in the ones column, Nana? You will be always getting 5 or 0. So whatever number you are taking, the ending ones place should be 5 or 0. Now, if I have taken a number that is 95, if you observe here, what is my ending digit here? My ending digit is 5. My ending digit that is in the ones place is 5. So 5 is divisible in 5. Therefore 95 is divisible by 5. One more example I am taking. My number is 680 and in ones place I am having 0. So 0 is divisible in a 5 table or not? Yes. 0 is divisible in 5 table. So therefore 680 is divisible by 5. If you want, you can cross check it out. How you will check it out? 680 divided by 5. Yes, this is our question. So now we will see. It should be divided by 5 table exactly coming remainder as 1. Means there should be no remainder. Remainder should be 0. Then only we can tell the number is divisible by 5. I am telling the ending number is 0. That's why it is divisible by 5. We will check whether it is right or wrong. So 5 ones are 5. My remainder is here 1. I am following with 8. So 5 threes are 15. Here my remainder is again 3. Now I am following with a 0. So in 5 table 5 goes for 6 times. 5 6 are 30. Now what is my remainder here? My remainder is 0. So it is exactly dividing the number. So it is divided by 5 table. 680 is divided by 5 table. Division with 5 table, remember, always 5 or 0 should be in the ones place. Then only we will consider that the given number or taken number is divisible by 5. Now we will see about divisibility rule for 6. How we are going to divide the number with a 6-digit number. If a number is divisible by both 2 and 3, then that number is divisible by 6. What is the rule here for 6? Whether the taken number is divided by 2 table or 3 table. Means you have to check whether it is divided by 2 table and 3 table. Not only with single table. With both the tables it should be divided. Means what is the rule for 2? Rule for 2 is one's digits place value should be the multiples of 2. What is the rule for 3? When you are adding the total number, the answer what you have got, it should be divided by 3 table, right? Now here I have taken one example. My example is here 246. Now first I have to check whether this number is divided by 2 table or not. For checking the number is divided by 2 or not, what I have to do first, I have to check the number in the ones place value. If I check the number in the ones place value, it is 6. So 6 is in 2 table or not? Yes, 6 is in 2 table. 2 3 is a 6. So the number what we have taken is divisible by 2. Now what is the divisibility rule for 3? You have to add all the digits in the number. So how I am going to add all the digits? I have to add 2 plus 4 plus 6. That is equal to, I got my answer 12. 12 is in 3 table, Nana? Yes, 12 is in 3 table. 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 fours are 12. Right, 12 is divided by 3 table. Now, in both the tables, the given number is divisible. It is divisible by 2 and it is also divisible by 3. So, the given number is divisible by both the tables. That's why the number is divisible by 6. If one digit is telling that it is divisible and the other digit is telling it is not divisible, then how you are going to tell it is divisible by 6 or not? You have to check in the two tables. In two tables you have to check. In any one of the table it is not showing the true statement, then it is not divisible by 6. Divisibility rule should accept both the tables. Both the rules are 2 and 3. Remember that carefully. Now we will check divisibility rule for 8. Divisibility by 8. A number is divisible by 8 if the number formed by its last 3 digits, or if a number is having 3 digits, you have to check whether the digits are divisible by 8 or not. So last 3 digits should be divided in a 8 table. Then only we can tell that is divisible by 8. For example, here 2544 is my number. Now I have to compare last 3 digits. Last 3 digits means you have to compare ones, tens and hundreds. These 3 digits I have to compare with 8 table. I have to see whether this 554 is divided by 8 table or not. If you want, you can check it out once here. What is my number? 544. So what I have to do? I have to divide this number by 8. So what is my answer here? 8 6 are 48. What is my remainder here? From 4 I can't remove 8. So what I have to do? I have to borrow the digit from the hundreds place. So when I am borrowing, it will become 4 and it will become 14. So from 14, if I remove 8, what I am going to get? If I am removing 8, I am getting 6 here. Now carry forward 4. So 8 8s are 64. What is my remainder here? It is 0. So the given number is divided by 8. So the total number is also divided by 8. Understood, ma? When you are checking divisibility rule for 8, you have to check the last 3 digits whether it is divisible by 8 table or not. If it is dividing in 8 table exactly by remainder 0, then you can tell the total number is divisible by 8. Now we will check divisibility rule for 9. For 9, it is same as 3. What we are doing in the divisibility rule for 3? Adding all the digits in the number and checking whether it is divisible by 3 table or not. Now, in this case of 9, we will be doing the same thing. A number is divisible by 9 if the sum of the digits is divisible by 9. So, sum of the digits means you have to add all the digits in the number and you have to check whether it is divisible by 9 or not. For example, I have taken my number 42,471. Now, what I have to do? I have to add all the numbers 4, 2, 4, 7 and 1. Now, how I am going to add? I am going to add it as 4 plus 2 plus 4 plus 7 plus 1. Now, when I am adding all these digits, what is my answer? 4 plus 2, 6. 6 plus 4, 10. 10 plus 7, 17. 17 plus 1, 18. So, 18 is divisible in 9 table? Yes, 9 ones are 9, 9 twos are 18. So, 18 is divisible by 9. So, the total number is divisible by 9. It is simple like divisibility rule for 3. 3 and 9 are same. Add the total number check whether it is divisible by 3. If it is divisibility rule for 3. If it is 9, check whether it is divisible by 9 or not. Now we will see divisibility rule for 10. Children, I hope you got some idea how to check the divisibility rules by seeing all the divisibility rules till now. Yes. When you are comparing the ones place value in 10 table, it should be always 0, right? So, whenever you are taking any number, if the last ones place value is having 0, then we consider that the number what we have taken is divisible by 0. Yes or no? When you compare your 10 table, what you will be observing? You will be observing in ones place value always it will be 0. Yes or no? 10 ones are 10. Ones place value 0. 10 twos are 20 ends with 0. 10 threes are 30 ends with 0. 10 fours are 40 ends with 0. 10 fives are 50 ends with 0. 10 tens are 100 ends with 0. 10 15s are 150 ends with 0. 100 into 10,000, right? So always the ones place value is 0. So whenever you see any number ending with a 0, we consider that the number what we have taken is divisible by 0. Example, I have taken my number 1570. So what is my ones place value? It is 0. So the number what we have taken is divisible by 10. Understand, Nana? Now, we'll go further. What is the divisibility rule for table 11? If you are going to check your 11 table, how you are going to check your table? A number is divisible by 11 if the difference of the sums of the alternative digits is 0 or multiple of 11. Here, we have to just check out the alternate numbers. First, suppose you have taken 5-digit numbers. You have to write alternate numbers. You have to add them and check the difference between the two numbers. When you are getting the difference as 0 or multiple of 11. What is multiples of 11? 11, 22, 33, 44, 55, 66, 77, 88, like that. So, if you are getting any multiple of 11, then we consider that the taken number is divisible by 11. For example, here I have taken my number is 9724. Here, what I have to do is I have to take the alternate numbers. What is my alternate numbers here? 9 and 2. 9 and 2. Then 7 and 4. What I have to do this alternate numbers? I have to add the alternate numbers. So what are my alternate numbers here? 9 and 2. 9 and 2 are my alternate numbers. So I am adding both 9 and 2. When I am adding 9 and 2, I am getting my answer as 11. In the same way, next alternate number is 7 plus 4. So what will be my answer here? It is 11. Now I have to check the difference. Both the numbers are equal, 11 and 11. So 11 minus 11 is nothing but 0. So the given number is divisible by 11. I got difference 0. So it is divisible by 11. Now I am taking my other number. It is 45,958. So what are my alternate numbers here? My alternate numbers are 4, 9 and 8. Again in the down reverse 5 and 5. These are my alternate numbers. Now what I have to do with my alternate numbers? I have to add my alternate numbers that are 4 plus 9 plus 8. So what is my answer here? It is 21. Now what is my second alternative numbers here? 5 plus 5. What is the answer here, ma? It is 10. Now I have to check the difference between the two numbers. What are the two numbers? 21 and 10. I have to check the difference between these two numbers. So which is the greater number here? 21. So write 21 first minus, what is my second number? It is 10. When I am checking my difference here between 21 and 10, what is the answer I am getting? I am getting 11. So this is multiple of 11. So the taken number is divisible by 11. So 45,958 is divisible by 11. Now we will see some more divisibility rules. We are going to see some more divisibility rules. What are some more divisibility rules here? If number is divisible by another number, then it is also divisible by each of the factors of that number. A number is divisible by another number. It is also divisible by the factors of that number. Yes or no? Here I am taking the number 18 and 72. 72 divided by 18 you are getting 4. This shows 72 is divisible by 18. What are the factors of 18? 1, 2, 3, 6, 9 and 18. Factors means what? The tables in which we can see the number 18, right? Factors means the tables in whichever we find 18, those are known as the factors. So 1 table and 18 table is common. Any number you take, 1 and the number itself are common. So in 2 table you will be finding 18. Yes, 2 nines are 18. 3 6 are 18, 6 3s are 18, 9 2s are 18, 18 ones are 18. So these are also the numbers which they can divide the number 72. When you are dividing the number 72 with 1, your answer will be 72 itself. When you are dividing the number with 72 divided by 2, your answer will be 36. When you are dividing your number 72 divided by 3, your answer is 24. When you are dividing the number 72 with 6, your answer is 12. When you are dividing the number with 9, 72 divided by 9, your answer is 8. And last, 72 divided by 18, your answer is 4. Therefore, 72 is divisible by each of the factors of the number. Understood, ma? Any number you are taking, it is divisible by a number, and whatever number you are taken for divisible, those for that number you are having factors. Those all the factors are also divisible by the number what we have taken. Understood? Now, if a number is divisible by two co-prime numbers, then it is also divisible by their product. What are meant by co-prime numbers, ma? Number which is having 1 as a common number, right? 1 as a common digit. Let's say 90 is divisible by 5 and 9. You can see 5 in 1 table and 5 table, and 9 in 1 table and 9 table. So what is the common digit there? 1 is the common digit. Those type of numbers are known as co-prime numbers. Now we have to see how we are going to work on this. As we know, 5 and 9 are co-prime numbers, so 90 must be divisible by their products. Product means what? You have to multiply these two numbers. 5 and 9 are co-prime numbers. What is those product? Product means multiplying, you are doing multiplication here. Multiple of the two digits is known as the product. So 45 is the product. When you are dividing 90 by the product, that is 45, you will be getting your answer 2. It is dividing exactly. So 90 is divisible by the product of the co-primes, that is 5 and 9. Understood, ma? Any number you take the co-prime numbers for that number. For that, when you are multiplying the two co-prime numbers, you are getting a product, and that product will divide the taken number exactly. So, the product of the co-prime numbers will divide the number what we have taken. If two given numbers are divisible by a number, then their sum is also divisible by that number. What is the statement here? When you are taking two numbers, if you are dividing the two numbers with the same number, the sum means the numbers what we have taken, when you add the two numbers, it should be divided by the same number what we have taken. So I will tell you one example for your understanding. If you observe this example, you will come to know what is the statement exactly. So I have taken two numbers now, that is 21 and 18. Now this 21 and 18, I am taking the number 3 as my divisible number. Now if you are checking 21 divided by 3, in 3 table you will be finding 21. Yes, 3 sevens are 21. So here I got my answer as 7. Now what is my next number? 18. 18 divided by 3. My answer is 3 6 are 18. So I am getting my answer here 6. Now what is the statement? Sum of the numbers, not the product what we have got after dividing. The numbers what we have taken actually. So what are the numbers I have taken actually? 21 and 18. So now I have to add 21 plus 18. So when I am adding 21 plus 18, my answer will be 39. Now I have to check whether 39 is divisible by 3 or not. It is divisible by 3 or not? Just add both the numbers. 3 plus 9, it is 12. 12 is there in 3 table? Yes, it is there in 3 table. If not, you can check in one more method, that is 39 divided by 3. Right? 3 ones are 3. Remainder is 0. Carry forward 9 down. Okay. 3 threes are 9. Remainder is 0. So it is dividing the number exactly. So the sum of the two numbers what we have taken is exactly divided by the number 3. Right? Therefore, 21 and 18 are divisible by 3 and their sum, and the sum of the two numbers is also divisible by 3. Now, if two given numbers are divisible by a number, then the difference is also divisible by that number. Before what we have seen, when we are adding the two numbers, we will be getting sum. Means addition means we are adding and getting the higher value. So that higher value is also divided by the number what we are taken. Now, here we are checking the difference. We are checking the difference. The difference, the lower number also should divide in the number what we have taken. For example, I have taken two numbers, that is 58 and 54. I am checking whether these numbers are divisible by 2 or not. For divisibility rule for 2 means what? Check out the ones place value whether it is multiples of 2 or not. If I am checking like that, here it is 4 and here it is 8. Yes, it is divisible by 2. We'll see here. 58 divided by 2, you are getting the answer as 29. And 54 divided by 2, you are getting the answer as 27. Now, what I told here, the difference between the two numbers should also divisible by 2. That is the condition. Yes, difference of the two numbers, that is 58 minus 4. What is your answer here? 4. 4 is there in 2 table? Yes, 2 2s are 4. Then 4 divided by 2, you will be getting your answer as 2. Therefore, 54 and 58 are divisible by 2. Then the difference, that is 4, is also divisible by 2. I hope you have understood all the divisibility rules here. Check out the rules by your own examples. Practice how many times you can practice with more number of examples, children. Children, now it's your duty, your exercise. Follow the exercise completely with the concept what you have learned in this class. If you have any doubts, you can get back to me. Hari Om. Thank you.